Hey everyone, welcome to my video presentation. So this project start with one question: Why modern AML system still fail still miss coordinates fraud? Okay, so this project called Network-Aware Explainable AML Anti-Money Laundering using hybrid anomaly detection from naive classification to production ready financial risk intelligence. So traditional system like traditional AML anti-money laundering system rely on statistics rules and binary prediction. But my goal was it to move to row level prediction to a network level risk intelligence, something that actually bank use. Okay, yeah, this is my problem and this is my project title. Next, move to next. Yeah, the silent threat. Financial institution lost billions annually to fraud and money laundering. The core challenge is modern fraud is adaptive, coordinated, and hidden. Current gap is statistic rules, transaction level checks, and high false positive. And the side image is that this is a fraud ring. These are the individual transactions and detection water pipeline. See the pipe. Upper side is the individual transaction and downside organized fraud ring. How fraudulent do fraud. Okay. How fraud. Okay. That's and move to next slide. The near failure, the role level trap. Initially, I tried supervised model like logistic regression, but recall was unstable, changing drastically with a small threshold casio. And why? Because this model assumed data point are independent. That's why. Recall instability. Metrics shifted widely between threshold zero point 0.3 and zero point 0.5. Okay, IID fallacy, logistic regression assume independence fraud is coordinated. Context blindness, the model show the row but miss the shared IP. So only the logistic regression find only the row, not give us a context why it's happened. Okay, move to next slide. The pivot from prediction to discovery. Old paradigm predictions, label data, supervised model, class 0 or 1. Impossible with weak label. Okay, weak label is impossible. New risk discovery, transaction data to like anomaly detection, explanatory and graph context. Okay, this like that. Detect structure without relying on perfect label. So that's why I changed my question. Initially, I asked whether this is a fraud or not, but then I asked, does this behavior look like abnormal and coordinated? Yeah, that's why it's the pivot. Pivot. Go through the next slide is okay. Fifth, the hybrid hypothesis. So my hybrid hypothesis is signal structure is equal to intelligence. Isolation forest do signals, graph intelligence do structures, and then gives intelligent explainable risk. Surface rare behavior what look abnormal. Isolation do what look abnormal in our data. And graph intelligence GNN, graph neural networks, validate relationship in it coordinate. So this hybrid, I make this isolation plus GNN, isolation forest plus GNN graph neural networks is equal to intelligence high explainable expert. Okay, moving to next slide. Surfacing suspicions with isolation forest. Why unsupervised learning? Why unsupervised label are scarce and fraud is rare? Why isolation? Why isolation forest choose? explicitly detect anomalies, scale to million of rows, output continuous risk score. Okay, so this is our normal data, this is isolation color, and this is isolation two color. This is an anomaly. Fewer colors is equal to higher anomaly score. So this is our anomaly, this is our normal data. So this is our this is our data, this is the outlier. So isolation forest do one thing only, take only do the give us outliers. Okay, yeah, so we move next slide. Okay, bricks with graph intelligence. Okay, this is a graph GNN. Without graph, this is a only anomaly. But with graph, share IP, device ID match, rapid sequence, isolated anomalies may be just wealthy user. Coordination detect mule ring conference. We use a graph not as a black box, but to validate relationship and propagate risk. Contextualizing risk with graph intelligence. An anomaly alone does not mean fraud. It could be a wealthy customer. So I added graph intelligence to detect coordination. Okay. Yeah. So we move into next slide. Oh, yeah. End-to-end architecture flow in Databricks. I make this project using Databricks. Okay. So first part is injection. Second, oh, okay. So first we see the code for raw transaction data is equal to injection. Okay. We'll go through the, okay. So this is our transaction. This is our Databricks code. So first, this is a bronze AML injection. So in a bronze layer, we do inject our raw data, and I use raw data with I use Kaggle raw data. Okay, Kaggle IBM raw data. Yeah. So this is a only like we put like inject the raw data. So this is a I use in this project IBM transactions for anti-money laundering. Okay, IBM transaction data. So this is our credentials. This is we make a create a schema of it. This is all normal code. Restart Python and then put data into our notebook. Okay, and this is a time stamp. Okay, yeah, that's it. Going to next slide. Next is that, okay. The next is feature engineering, cleaning and aggregation. So the next is silver. Silver in silver AML, like silver transaction. We do only you know we do only cleaning, feature and aggregation. Okay, so first this is a silver volume. We make a volume. If it's not a volume, make a in a workshop. Okay, then bronze data uploaded, then make a cleaning. This is unnamed. Whenever you in your in your calculator there is you have unnamed column. You want to remove it, then you remove it. Okay, then we make a feature engineering, which feature is perfect or not, and then it's a silver transaction. We have for 30 million rows, and then delta table. Okay, this is a give us a data level, select min max timestamp. What is timestamp? Like timestamp. Okay, transaction timestamp, like that. Okay, and then silver node. Okay, it's give okay, then we goes into the silver. Also this is a in a silver notebook, this is node feature isolation forest. Okay, silver TNX transaction. Okay, this is a code of it. And yeah, this is a code of a node feature selected, how much feature we want in our data. Okay, this is a last SQL select count from workspace AML fraud dot silver node feature is equal to 99 1 lakh 99314. Okay. Okay, then we go isolation forest and graph build structure, like isolation signal and graph structure. So first we move on to a isolation forest training. Okay, like how we do isolation, and okay, how we do isolation forest in it. Okay, yeah, this is a silver node. We previously did it. Works are AML for silver node feature. We first, load this data into a isolation feature columns. What we need and what is the our target variable. Okay, if we have the two pandas, we convert into a pandas with fill NA with a scalar. Okay, scalar dot fit transform PDF feature columns. Okay, and scalar use standard scalar we use in it for a scalar and assembly isolation forest and estimator 200 contamination 0.04 random stage 42 and end job -1. Okay, this is too straightforward to in isolation. This is an estimator, like how which estimator we have, like we do contamination, like how much the isolation predict. This is a see in our this book. Contamination means this is a our outlier. So how much part isolation do into a outlier? Like when we do 0.04, then this part or those part are in a outlier, and those part are in a like this is our normal data. This is a fraud. This is normal data in a simple form. Okay, but this is not a fraud. But we like we say like that. This is a fraud. This is normal. Okay, it's called contamination. Okay, and then this is a flag. Okay, its PD is anomaly values, like 0 is a line on 300 195,327 and 3987. Okay, and then matplotlib. Okay, this is a matplotlib graph by how looks like our data. This is an anomalies all are, this is a normal data, like overlap the old data in it. Okay, yeah, and yeah, that's it. This is a normal. This is a we see is anomaly. How much anomaly is that? Okay, and then we go to the gold graph for 50 days, yeah, so 80 days. Okay, this is a gold graph because this is a this is 430 million rows. This because that's why GNN not adapt to all 430 ml 30 million rows. That's why I build to go to the only 80 days, only 50 days, oh sorry, 80 days data transaction, and then put into a GNN training. Okay, yeah. So I make this only 80 days, only 80 days to make make this into a it. Okay, yeah, 80 days have a this type of rows, but it is small to the all over data. Okay, then we go to a GNN training. Most of part of GNN training is that okay. This is a GNN, like this is a graph, like this made a graph and our transaction, like neighborhood, and then give us yeah, like that. Okay, like give yeah, we see code and then I explain you. Okay, first we see. Okay, yeah. So this is our 6 GNN training. Yeah, this is a all dependency. We want to download it. Okay. Then first we like goal graph, how many rows we input it in the it, like how many row we put into a GNN graph. Okay. This is all stuff like how which is this SRC ID and distance ID. Okay, DST ID. Okay, the collection is counter. Yeah, fraud node is equal to set edge is equal to pd dot lock. Okay, then from scikit-learn model selection train test split, we do the train state train test split, and then do it. Okay, this is the index. Okay, for taught geometry data into data is x equal to x, age index is equal to age index. Okay, yeah, normal is okay. Yeah, that's, and then right now, then now we use GraphSAGE. Okay, import torch.nn function as f from torch geometric n and import saga convolution neural network. We use GraphSAGE. Okay, okay. So we use GraphSAGE in it, and yeah, this is our Saga neural network. Okay, then model graph saga optimizer torch optim adam, this is adam, design torch.nn, this is all stuff. Epoch, we run epoch, range to 1 to 101. Okay, this is 100 epoch we run. Then we print main part of it gen ai, like sorry, no, not gen ai, jnn training. Main part of it, it's a confusion matrix. This is a our confusion matrix. This is a precision 9.73, recall 1, accuracy 9.93. And this is our, I predict the, how much in our data, how much is a high fraud, medium fraud, and low fraud, like that. Okay. But in this, I face one problem is that this is a, confident model. When I put in synthetic data, it's give me amazing, amazing, like not give, sorry, I put this data into our, okay, and I save it. Okay, and then when I put into our synthetic data, it's not give me a that like confusion matrix or precision recall or accuracy. It's not like that. It's give me a not better precision recall. So we do a GNN evaluation, 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 evaluation. So, oh, this is a wrong file. Yeah, this file I have. Okay. Yeah, this is the evaluation file. I like load this data. This is all stuff like that. This is load data or else. Okay. Like we do a evaluation our matrix. Okay. So also I see one thing, how this is okay, how can we like make a better to on it. Okay, so this is our threshold, like we make a iteration, like this is a base threshold, which is a base threshold over it. This is a, when we put a 7, we put a 3, it's give us a different model and different one. But when I put a 0.77070, it's give me a perfect in it. And then, okay, this is a trial and error process to like whenever like best you try 3, 2, 1, whatever you want, and then try, and then it's give us a perfect confusion matrix. Okay, those all our problems. Okay, evaluation GNN. Okay, then we move into next slide is equal to engineering the data. Yeah, melanin architecture. Okay, bronze, silver, gold, raw data, synthetic sets, schema information, audit terrain. Okay, refining logic, clean data, feature engineering, and it is resolution. Graph age created. Okay, graph age we created, graph node we created, intelligent table, anomaly score, network flag, actionable, actionable actionable risk. Okay, yeah, the threshold come out that with the threshold option validating models. Accuracy is meaningless in AML, anti-money laundering. Accuracy does not matter in AML systems. We optimize for a recall versus fatigue. Okay, so this is our diagram to make this a percentage. This is the thresholds. Okay, so when I 0.6, my operational sweet spot recall high, but my forward down logic validated on unseen synthetic data to ensure stability. Okay, so in this data, okay, in this evaluation GNN, we run a synthetic data to validate our model, how our model replied to a unseen data, and how it put like that. Okay, So we do the synthetic, make a synthetic data and run on it this our model. Okay, and do thresholds to like how much threshold do I give a best model, like that. Okay, so this is our this is our synthetic data book. So this is normal. We want to download. This is a saga predefined. This is a model when we put in into it. This is a num how many we want, like 30% fraud. Okay, 30% we want to fraud and 70% is a normal. Okay, so we first decided 70% are normal and 30% are fraud. So then we know the how the confidence metric answer our model. Okay, you see 10,000 nodes is 10,743 nodes. Okay, ages. Okay, so this is see, this is our threshold to make iterative process. So print threshold, precision and recall. Okay, and we want in anti-money laundering system, we want precision recall high. Okay, why I give you a example, then you understand why I say precision recall I we want to high and accuracy meaningless in this anti-money laundering or fraud detection. Okay, so this is a threshold when we like 40 in I, like 100 for I in range 25, 71, 1. Okay, we do those all things, and it's give a thresholds which threshold are based for our model and synthetic data. Okay, and like the threshold we make a 70 like that, and then it's give us a like that accuracy, like when we do 70 and I run, maybe it's run, yeah, it's run like precision 1 and recall 7 0.767. Oh no, it's run right now. Okay, okay, can we run this or not? Okay, okay, no. It's give us problem because we don't run to all those things. First we run it and it's give us a threshold and answer, threshold answer, like that, threshold answer. Okay, okay. Okay, yeah. See, it's give a threshold to answer. Like how, like I did 0.70, it's give a precision 1 and recall 0.71 and accuracy 0.9931. Okay, but when we do like I want this 60, I want only 99% of recall and 99% of precision. So I do 60 and run this. Okay, wait, yeah, like that. It's give us a perfectly answer. Like okay, okay. I predict this. Okay. Oh, DF is not defined. Okay, now make this sense. Okay. Okay. Oh, yeah, just like that. Yeah. Come to the next. Okay. Confusion matrix. It's predict the confusion. Yeah. So our I explain you confusion matrix. What does that mean? What this mean? First, uh, normal account correct ignored. Okay, normal account true negative. First 6989 is our true negative value. Second is a false positive, normal fraud. Okay, 11 normal account flagged as a fraud. Like we have a normal account, but it's flagged fraud. 11 fraud. Like okay, false negative, fraud to normal. This is a fraud account, but it's missed and give a fraud. This is normal. It's high 151. These are slipped. We want to this low. Okay, true positive, fraud 2849, fraud account correct. This is where the banks save money. Okay, And then metrics summarize precision equal to when the model says fraud, how often it is correct, how much total fraud the model is able to catch, and overall correctness not the main focus in a fraud. Okay, output transaction 200 for the fraud we are collecting detected on a fraud slipped 11 normal account and 6 normal accounts were safely ignored. Okay, it makes sense. And then we make a bucket list like that. Okay, first we see the next slide and then go that. Okay, so this is a threshold, like I tell you problem, try error like that. Okay. Okay, operationalizing initially the dashboard. Like, what is the dashboard? We want a dashboard like where we put into it like this type of dashboard. Like I make. Okay, and also I make the Streamlit one. I I'll explain you where. Okay, so the binary beyond the composite risk score. Okay, this is a anomaly intensity 40%, behavior deviation 30%, network indicators 30%, anomaly intensity. Okay, base reality change it pattern, guilt by association. Score is equal to W1 into anomaly, W2 into behavior, W2 network. We replace binary zero prediction with a tier ranking system. We do a one tier ranking system that we replace 0 and 1, like this is fraud or not. We do this like that, anomaly intensity, behavior deviation, like what is the behavior, network indicator, like network indicator we do, and also we do into a weight of it. Okay, beyond the binary, beyond the binary, the composite risk score. Okay, only risk score is a like that, solving the black box rule mapped explainability. Okay, the black box is a, the logic is in the order as it's give a model output like this, yes or no. Investigator, why? No answer. The question is that the black box is model output is 0.98, but the core question is why we predict that answer is known. Okay, the explainer engine risk level high, reason 1 transaction volume 300% of average, reason 2 share device ID with case 441 confirm fraud. Okay, complaints require reason, not just probability. Okay, this also we see in the next. This is our account id. Whenever uh, data set have fraud, it's give us a account number, and then also fraud probability, also actual label, and also risk bucket, how risk is this account. Okay, okay, then next is, okay, yeah. Okay, so next we make this okay, rerun it. When we rerun, it's reloaded. Okay, yeah, this is our, I make this uh same logic, to a isolation plus GNN, but in this I only make a isolation with isolation. This is a fraud detection investigator dashboard in using Databricks. This is same concept. This is the same output. This is same logic of it, but in Databricks I cannot put a GNN into it with Streamlit. That's why I put only using a isolation. But isolation it's give a better answer to it. Okay, so the bronze injection transaction graph is that our, this is all are same, but I make this into ChatGPT, not a ChatGPT, make this data set and then make whole thing. Okay, so what does they do? Okay, the do. Okay, yeah, so is a print schema or else this is all stuff we see in the previous. These are all are same, all are concepts same, all are like Melodian same, like bronze, gold, silver, bronze, silver, gold, like that. Also, this is a silver transaction cleaning. How they clean? Okay, like this, and we have this type of account id, device id, ip address, transaction id, amount, event ts, and phone number, email. Okay. Silver df, we have those type of id, this those type of data set. Okay. The third is featuring it with isolation forest. Okay. We use isolation forest with it. Okay. So these are Python function of call, IP. This is all are normal. This is C. Also in this we use contamination is equal to 0.05. So assume 5% of suspicious in our data set. Okay. Then we go to the next. This is a 4FA gold graph construction. This is our gold graph construction. Yeah, it's this normal. This is a goal graph construction. And then 5 is our F in new data. Our like we have a like new data, like we create a new data of it. Okay. This is account ID, node ID. Okay. We only make this into with isolation forest because GNN not supported into Simrit. Also in my future plan is that we make into, like, when I click browse, like click into a single trigger our job lines, and then make to all those things like isolation GNN, and then it's give a answer. I will make into a in future. Okay. Yeah, this is all stuff, how much row we have. Okay, this is all stuff we doing. Oh, I doing that. Okay. Yeah, this is all normal stuff. Okay, then we move into the app.py. This is the main function. Okay. Wait. Okay, I want to see what is the answer it's give. Okay, I see previous. Okay, this is our app.py. There is a main code of this is behind the Streamlit app. Okay, this is the main code of it. This is a requirement.txt, and this is app.yml. Okay, so this is fraud detection invocation dashboard. So first we browse file, transaction data with feature. Okay, okay, rerun it first. Okay, yeah, yeah. Yeah. Also, the first thing, I want to say, this is a four row we use mandatory to it. Is that unique target, is anomaly, average amount, and total amount. We mandatory to do this in every a bank data set. Okay. So fraud illustrating table, it's give us a, like, first account. These all are fraud. Okay. Account 1605. We also search account, yeah, 1605. Done it. It's give us all this report to it 01 the okay. I explain you a better way. Account ID ACC 1605. Fraud probability 09169. Risk level high, total amount contribution, like this total amount in this 1605, its contributor 94.131 percentage of this fraud probability. Like how this account be fraud, like how we say this account be fraud, because of this total amount contribution is in 94%, average amount contribution 5.83%, and unique target contribution account 0.02%. That's why fraud reason is a high total transaction volume, statistical anomaly detected. It's give us also email, phone number, IP address, device ID whenever data set have. Okay. Okay, then I move next. Okay. Why? Okay, yeah. Okay. It's seems like wait, we do rerun. Okay. Fraud baseline. Okay, it's rerun. We don't want this file. Okay, first we refresh it. I don't know why. What's happened? Okay, yeah, that's why it's give us a yeah, yeah, running. Okay, running those data running. Which like it using account ID. Okay, wait. Yeah, it's give perfectly. Okay, where is the account or account ID? Okay, so that's why this is a average amount contribution. Like what is does mean total amount contribution, average amount contribution, unique target contribution? It's mean how much contribute to this fraud, this account to be we say the fraud probability. How much how we say this account fraud probability is 9.1. How? Because of this is a total account contributed to on it. This is average amount contributed and unique amount contributed. It's give us that answer. Yeah. And yeah, so we next move into next slide. Okay, yeah, this problem solve my Streamlit app. Solving the black box is rule map explainability. Like this black box, it's give us a, like this is a model output this, but explainability why this called 98% model output why it's and also risk level high, but why risk level high? It's give us a explainability. Compiles complaints require reason, not just a probability. The next is delivering value to the financial ecosystem. Early detection, catching risk before the money exists. Okay, we make early detection model whenever early detection happen, it's catching risk and before the money exit. Like when money exit, then early to detected. That's why network awareness exposing ring that standard rules miss. Okay, efficiency, reduce false positive, save investigator hour. Efficiency, reduce false positive, save investigator hour. Okay, safely and complaint defensible and explainable audit details. Then next is yeah, model choice is a risk decision. We move from naive prediction to a network intelligence grounded in the real world constraints. And effectively, AML system does not just predict; it's illuminated the unknown. The project show me that fraud isn't about a transaction; it's about a network and where real AML intelligence begins. Anti-money laundering. Okay. And also, this is a research paper to a Zakaria ETAL. I read because this is a man to this same do it GN isolation plus GNN. Okay, yeah, this is a model risk decision. Okay, so this is our video presentation. Network aware explainable AML using hybrid anomaly detection. Thank you for thank you for watching.